and a warm welcome to the AI with Arun show. In today's episode, we'll dive into a topic that is rapidly reshaping conversations in software development. It's called vibe coding. Is it the next revolution in how we build software, or is it a potentially reckless path? We'll go beyond the hype to offer a deep, insightful look into the future of AI driven software creation. We have seen AI evolve rapidly from basic code completion tools to more sophisticated code generation platforms like OpenAI's Codex and GitHub Copilot, which really took off in late 2022. Then in early 2025, the term vibe coding burst onto the scene, igniting intense debate and capturing a distinctly new AI centric approach to building software. This isn't just about adopting new tools, it's forcing us to fundamentally rethink how we create software. Today, our objective is to dissect vibe coding, explore its origins and mechanics, and undeniably allure, its significant perils, and the profound implications for developers and the industry as a whole. So, where did this term actually come from? Understanding the context is crucial. Vibe coding is widely attributed to Andrej Karpathy, a prominent figure known for his work at OpenAI and Tesla. He introduced it in a social media post in Feb 2025. The original description painted a picture of fully giving in to the vibes, embracing the AI's flow, and almost forgetting the underlying code exists, accepting that the result mostly works. But here is the critical initial context. Karpathy explicitly framed this for throwaway weekend projects. Think experimental, low stakes, maybe even playful exploration, not necessarily professional grade engineering. This idea connects to his earlier prediction in 2023 that the hottest new programming language is English, foreshadowing the shift towards natural language interaction with machines. The key insight here is that the term's casual origin often contrasts sharply with how it is discussed and applied in more serious contexts today. And this discrepancy fuels much of the surrounding controversy. So let's reconstruct what vibe coding actually entails. At its core, the practice involves instructing AI models, specifically large language models, using natural language prompts to generate software. The human role shifts dramatically from authoring code line by line to becoming a prompter, a guide, and a tester of the AI's output. The underlying philosophy prioritizes the creative intent, the vision, and the user experience, essentially forgetting that the code exists. It's a process often driven more by intuition and iteration rather than by rigorous planning. But here lies the crucial distinction, emphasized by commentators like Samuel Willison. Vibe coding, in its purest sense, isn't just using AI. It implies potentially accepting AI generated code without conducting a full review, performing thorough testing, or achieving a complete understanding of it. Simply using an LLM as a powerful typing assistant where the human retains full oversight and understanding is not vibe coding by this stricter definition. The core controversy, therefore, revolves around this potential abdication of deep understanding and rigorous review, not merely the presence of AI in the workflow. This distinction is absolutely central to the debate. So, how does vibe actually manifest in practice? The workflow is typically iterative and conversational. It starts with a natural language prompt. The AI generates code, the user then runs or tests it, often focusing on whether the outcome looks right, rather than scrutinizing the code itself. If it's buggy or wrong, the user refines those prompts, perhaps even pasting error messages back into the AI, asking for fixes or changes. This cycle repeats until the user is satisfied or decides to work around remaining issues. This process exhibits several key traits: incredible speed and accessibility, lowering the barrier to entry, a reliance on intuition over rigorous analysis, a potential opacity where the user does not fully grasp the generated code, and an acceptance that the result might only mostly work, containing bugs or glitches. And underpinning this is a growing ecosystem of tools, platforms like Replit with its agent, AI first editors like Cursor with its YOLO mode, established players like GitHub Copilot, and general LLMs like ChatGPT and Claude and Gemini are all approaching this approach. The insight here is that the emergence of these specialized tools signals real commercial interest and momentum, pushing the practice forward even amidst the debate. Given the potential downsides, we'll discuss why are people embracing the vibe, There are several perceived advantages. Firstly, democratization. It significantly lowered the barrier for non-coder entrepreneurs, designers, hobbyists, allowing them to build functional applications. It empowers the creation of personalized software for one. Secondly, accelerated innovation. It's incredibly useful for rapidly creating prototypes, minimum viable products, MVPs, and validating ideas quickly. The speed aligns perfectly with lean startup methodologies, emphasizing fast build, measure, learn cycles. Thirdly, it can be a tool for learning and exploration, potentially flattening the initial coding curve or helping experienced devs explore new technologies. Finally, by abstracting away implementation details, it allows the creators to focus more on the product vision, user experience, and core creative ideas. The key insight is that vibe coding's strength seems aligned with the dynamics of early stage innovation, where speed and iteration are paramount. It shifts the bottleneck from technical implementation to idea validation. However, this speed often comes at the hidden cost of significant technical debt. Now for the reality check. Despite the allure, vibe coding is fraught with grave risks and has drawn sharp criticism. First and foremost is the potential for a code quality catastrophe. Code generated this way, especially without rigorous review, can be buggy, inefficient, insecure, and lack coherent structure. This leads directly to the second major issue, maintainability and scalability nightmares. Trying to evolve or scale software built on poorly understood fragile code, often described as spaghetti garbage drums, is incredibly difficult and costly. It's generally unsuitable for complex, large scale systems. And third, we face the security relay. AI models can easily generate vulnerable code, introducing flaws like cross-site scripting or authentication bypasses, if not meticulously guided and reviewed. This raises serious questions about accountability when things go wrong. Finally, there's this debugging quagmire. The sentiment, vibe coding is easy, vibe debugging is hard, is widespread. Trying to fix code you didn't write or don't understand is notoriously painful, and AI assistants often struggle to fix the very bugs that they introduced. The insight is stark. There aren't minor inconveniences, they represent fundamental threats to software reliability, security, and longevity. But beyond the technical risks, there are deeper concerns. One is the philosophical peril of descaling. Does over reliance on AI to generate code erode our fundamental understanding of programming principles, algorithms, and system design? As Richard Feynman famously said, what I cannot create, I do not understand. Are we potentially creating a generation of developers who can prompt effectively but lack deep engineering insight? This concern feeds into widespread industry skepticism. Many experienced developers dismiss vibe coding outright. They see it as a stupid name, a misleading buzzword, simply a rebranding of careless coding or rapid prototyping with its known limitations or marketing hype, or pushed by AI companies. Some draw parallels to past mistakes, like relying on low quality software development, offshore software development, that ultimately required expensive rework. The insight is that this intense debate reveals deep anxieties within the profession about AI's transformative role, the very definition of developer skill, the trade offs between rigor and speed, and the future identity of software engineering itself. To truly grasp why coding's place, we need context. How does it stack up against established software development practices? Compared to agile or waterfall methodologies, vibe coding lacks the structure, collaborative process, and defined roles. It's generally more chaotic and less predictable. Against test driven development, it's practically the polar opposite. TDD mandates writing tests first to drive design and ensure quality, whereas vibe coding often neglects rigorous testing, making it an afterthought, if considered at all. Compared to low code, no code platforms, which offer visual control over predefined abstractions, vibe coding uses probabilistic AI to generate factual, often opaque source code. This offers potentially more flexibility, but comes with far less predictability and transparency. And crucially, compared to responsible AI assisted development, the key difference remains this level of human oversight and understanding. Responsible use sees AI as a tool under human control, review, and comprehension, while vibe coding in its extreme form involves delegating agency to the AI, potentially bypassing that critical human element. The insight is that vibe coding occupies a unique, high risk, high speed niche, fundamentally trading established engineering disciplines for the allure of rapid AI delegated generation. Now, the developer community itself is highly polarized on this topic. As seen in discussion platforms like Reddit and Hacker News, we see a spectrum of views. There are enthusiasts excited by the speed for MVPs and personal projects. There's a large contingent of skeptics dominated by fears about quality, security, and maintainability. And there are pragmatists who see AI as just another tool, valuable if used responsibly with human oversight and review. This debate naturally leads to the big question: what's the impact on developers and their roles? Discussions suggest a shift away from manual coding towards high level tasks like effective prompting, managing AI agents, tackling complex debugging challenges, system design, and ensuring quality. This raises questions about the job market. Will it put pressure on junior roles focused on rote tasks? Will it increase demand for highly skilled senior engineers needed to guide AI, architect systems, and ensure quality? Or could it even generate more work by enabling more prototypes than need professional rebuilding? The likely insight is that AI is accelerating a bifurcation, automating lower level implementations while making high level cognitive skills like system thinking, critical debugging, and architectural design even more valuable. So, where does this leave us? Vibe coding today is a nascent, hotly debated concept embodying the tension between AI driven speed and traditional engineering rigor. Its practical application, especially in its less rigorous forms, seems largely defined to low stake scenarios where the risks are acceptable. For example, personal projects, prototypes, learning exercises, etc. Looking ahead, AI capabilities in coding will undoubtedly continue to improve rapidly. We can expect elements of AI assistance to become more integrated into workflows, but likely coupled with stronger safeguards. Think AI assisted testing, formal verification, automated security audits, and robust human in the loop systems to mitigate risk. Voice to code interfaces might also become more common, and we could see hybrid no code AI platforms emerge. So, what is the recommendation? Proceed with caution and skill. Use these techniques strategically where the trade offs make sense. Accelerating prototypes, facilitating learning, building low risk tools. Master prompt engineering, yes, but never abandon software engineering fundamentals. Crucially, maintain human oversight. Review, test, understand, and keep the AI on what Karpathy himself later called a tight leash. The insight is clear. AI is a powerful amplifier, but it is not a magic wand that replaces diligence. Now, this brings us to the final crucial point. In the age of AI, core software engineering principles are not becoming obsolete. They are becoming more vital than ever. The rise of powerful AI assistants does not eliminate the need for solid engineering, it heightens it. Critical human skills remain paramount. The ability to clearly define requirements, design sound and maintainable architecture, reason about complex system behavior, ensure quality through rigorous testing and review, maintain a security first mindset, effectively debug intricate problems, and collaborate effectively. The future isn't about choosing between human developers or AI. It's about skilled humans leveraging AI responsibly and effectively. Let's embrace the power of these tools offer, but let's also commit to mastering the craft. Engineering rigor is our essential anchor in the midst of this AI storm. With that, we come to the end of the show. Thank you for watching the AI with Arun show. Do let us know what you think in the comments below.